Okay, I forgot to press record when I did my question 18 before, so I'm going to do this question unrealistically fast because I've already got the solution over on another sheet of paper that you can't see. We've been told that there's 3 points. This is A, negative 1, comma 0. This is B, half, comma, root 3 over 2. Trying to keep my diagram reasonably accurate here. Root 3 is 1.7-ish. Divided by 2, you get a little bit less than 1. I immediately notice, because I train myself to notice when a question is constructed with numbers that are coincidentally the same. It's very, very important to be on the lookout for that, because it means you can do questions fast. The fact that these two x-coordinates are the same means that this diagram is very easy to draw neatly. And the fact that that is the positive version of that means that I could be 100% sure that this top triangle is congruent to that triangle. Okay, so what do I have to do? I have to verify that all 3 of those points are on this circle. Just sub them in. Okay, so that's part A. Part B, you have to show that this is an isosceles triangle. Now there's 2 ways of doing this. They're both very quick. Work out that distance. That distance is obviously root 3. Because it's root 3 over 2 above, it's root 3 over 2 below. The distance that's the distance BC I've just worked out. The different distance AB is just a little Pythagoras question. It's distance formulas question. That minus that is 3 over 2. Square that. That minus that is root 3 over 2. Square that. Square root the sum. You get 9 over 4 plus 3 over 4, which is square root of 12 over 4, which is root 3. Distance AC has to be the same, because it would be the same calculation just with a negative there that would get squared immediately. So there we go. We've got 3 distances that are all equal. Therefore, ABC is a right-angled triangle. Oh, sorry, is equilateral. Now, don't forget that your basic GCSE toolkit is available to you whenever. Okay, I pointed out that the neatness of this diagram assured me that this was an isosceles triangle, because that is congruent to that. So therefore it's pretty easy to work out this angle. What is that angle? Let's do SOHCAHTOA on it. That is root 3 over 2 distance. That is 3 over 2 distance, because it goes from negative 1 on the left to half on the right. It's 1.5, which is 3 over 2. So tan theta is equal to the opposite over the adjacent, which is times top and bottom by 2. 3 over root 3. Rationalize the denominator. You get root 3, which tells me that theta is 60. That's one of the ones which you're just supposed to know off by heart. Now, because ABC is isosceles, it must also be, so because ABC is isosceles, it must also be equilateral as one angle is 60. If one angle is 60, then the other 2 have to be 60 as well, because that's the only way to fit such angles in a triangle. I've already solved the problem. That was just me demonstrating that SOHCAHTOA can be useful to you at any point where right-angled triangles are at play. Question number 19. Okay, so 2, 2 is a point. Oh, this is another question with quite small numbers, so I'm going to call this 2, 2, that's called P. 2 plus root 3, that's about 3.7, comma 5, so it's 2, 3, 3.7, 2, 4, 5. That's called Q, 2 plus root 3, root 5. It's very important to have a good sense of how big these numbers are. That's a little bit more than 1, it's a little bit more than 3, it's a little bit more than 2. Just whenever you need to get a sense of how big a surd is, just compare it to the nearest square number So 82 has to be a little bit more than 9 because 82 is a little bit more than 81. Just helps you keep your diagrams relatively accurate. And finally, 2 minus root 3, comma 5. Very important to spot coincidences like that. Well, I've drawn 2 minus root 3. So that's a little bit to the right of the, and it's got the same height. Important to notice that coincidence. That means you got a classic congruent triangle situation. You got 2, you add something, go to the right, you add something, go to the left. Those are 2 of the same, those 2 points have the same height, so of course this triangle must be congruent to that. There's no other way for it to be. It wouldn't be good enough as a proof in the GCSE that they were congruent, but it's certainly good enough for me to be satisfied that this is a accurate representation of the situation. We've been told that on a circle. And the equation of that circle is this. Got almost all the details there except for the r squared. Our first job is to find r. Let's just sub in a point. Whenever you sub in a point to the equation, you should get something true. So 2 minus 2 squared plus 2 minus 4 squared equals r squared. So negative 2 squared equals r squared, so r squared equals 4, so r equals 2. Normally there'd be 2 solutions to that. In this case there's only 1 because r is a positive number. So the radius is 2, so that's part A. Part B, we have to show that this is equilateral. That distance there is clearly, I better name these, what was that? So it's PQR. That distance is clearly 2 root 3 because there's a centre there, it goes root 3 to the right, root 3 to the left, so it's 2 root 3 across. This distance here, well actually no, like in the last video, I'm going to use SOHCAHTOA here. That distance there is clearly 3 because this point has a y coordinate of 2 and this point has a y coordinate of 5. I'm just trying to do it the fastest way. Of course you can do the distance formula on this, distance formula on this, and distance formula on that. Get the same answer 3 times, it'll be equilateral. I'm just trying to save a bit of time. So if we call that theta, then tan theta equals that distance, which is root 3, over that distance, so the opposite over the adjacent, which is 3, and therefore theta equals 30. So therefore angle RPQ equals 60. Therefore angle triangle RPQ must be equilateral as it contains 60 and is isosceles. Question number 19. Oh, just before I go on, I'll just talk about why I'm so sure that those two triangles are congruent. I think it would be a side-side-side proof. That is equal to that, common. That is equal to that, because they're both equal to root 3. And actually, and that is definitely equal to that because it would be the same distance formula question. I'm pretty sure. Yeah, because when the difference between these x coordinates is root 3, and the difference between these x coordinates is negative root 3, and therefore the same thing would get pumped into the quadratic formula. So that's why I'm so sure that those two triangles are congruent. Another way to be sure is to be sure that that's a right angle. You can be sure that's a right angle because the midpoint of these two, which is clearly 2, is directly above the x coordinate of P. So that will be a side angle side congruence proof. Okay, question 20. Almost there. Only got 4 more questions to go. So A is negative 3, comma negative 2. Trying to have as much information on the diagram as possible so I can look at it as a central location of all of my information. Negative 6, comma 0 is B, and C is the mystery PQ. Before I draw that on, I'll just read on a bit. Negative 2.5, comma 2 is the center of a circle. So, yeah, negative 2.5, comma 2 is the center of a circle. Now, BC is the diameter of the circle. The word diameter should absolutely direct you very, very fast to the famous circle theorem that triangles built in circles using diameters are always right angled. So this circle here has a right angle, this triangle there has a right angle there. That's C, that's P, comma Q. Now our job is to find the coordinates of P, comma Q. I'm going to do this as a backwards question because I know the midpoint. So P plus negative 6 over 2 has to come out as negative 2.5 because it's the midpoint. 0 plus Q over 2 has to come out as 2 because that's the midpoint. So therefore Q equals 4 and P equals 1. Just solving those equations. So that's part A. Part B, find the gradient of AB. The gradient of AB, this is what I'm going to do with my snappy little saying. You go the second y minus the first y over, so this is this gradient AB. Second y minus first y is negative 2. Second x minus first x is 3, so that's negative 2 over 3. The gradient of AC is, so we now know that that's 1, 4. Again, try and update the diagram so you can look at the diagram and see all the information you need. So, second y minus first y is 6. Second x minus first x is 4. Simplifying stuff helps you spot. And here's the pattern. That and that are negative reciprocals of each other. So MAB times MAC equals negative 1. That's just a faster way of writing negative reciprocal. That's done. So AB is perpendicular to AC. Now, of course, we already knew that because I pointed out before. The moment I was told that was a diameter, I knew that that had to be a right angle. Now, that means that there's an alternative to part C. I bet you anything in the real exam, part C would be worth just 1 mark, which means you could just say very quickly, AB must be perpendicular to AC because the angle in a semicircle is always a right angled. Because a triangle in a semicircle is always right angled. And that will be done. That will get you the 1 mark. Now, question 21, 22, 23 and 24 are all the same, so I'll just do one of them. X squared plus y squared minus 6x minus 2y minus 6 equals 0. We've got to find the centre and the radius. We've got to make this look like the classic template of a circle. When it looks like the classic template of a circle, we can decide the A, the B and the R just by looking at it. Now, let's say you're stuck here. What problem-solving strategy would you use? Well, there's a problem-solving strategy called where did I last see this? Like, when was the last time I took something like this and made it look like that? Well, it was completing the square. So we're just going to complete the square. We're going to do it twice. I always think of completing the square as hating what's in third position. So you create a space for what's in third position. I don't like the fact that this is a -6, so I've just bumped it along there. What would I rather have? There I'd rather have a 9. Just halve this and then square it. Here I'd rather have a 1. You cannot just randomly put 9s and 1s there, but if it's an equation you can, because you just introduce them via a red dude, add them to both sides. Then you factorize this. It's been specially designed so you get the same bracket twice. So the center is 3, 1 and the radius is √10. Change your mind, I'll just do one other example of that so you can see the method. So x squared plus y squared minus 10x plus 16y minus 11 equals 0. Let's complete the square twice on that. There's the third position blank. There's the third position by bumping out the 11. What would I like to have in there? Halve this, you square it, you get 25. Put that in there. Halve this, you square it, get 64. Put that in there. Acknowledge that you cannot just randomly... I realised I've made a mistake here. On this previous one, I completely forgot about the -6. Sorry about that. Now, okay, so factorize these. Having a shocker. Okay, you can't just introduce the 25 and the 64, you have to introduce it with a red dude. Okay, so that's now 89 plus 11 will be 100. So the center is 5, -4, and the radius is 10.